everyone, welcome to our comprehensive series on radiation biology and protection. In this lecture, we'll cover the foundation. What is radiation biology? Right? Why does radiation biology matters? Why does radiation protection matters and the historical context um, to it as well. Moving on, what's radiation biology? Radiation biology is just the study of how ionizing radiation, how they affect the living organisms, how energy transfers from radiation leads to biological damage. And we're going to focus on the cellular and the molecular levels. When a patient is exposed to radiation, a level of energy is being deposited. So some of the damage that this deposit causes is what we would be looking at. And remember that every time we use x-rays, right, like I said, we are depositing energy into the patient's tissue. And that energy has its consequences. It has its own good effects, it also have its side effect. So we want to understand, in as much as this thing has been very helpful, it's helpful in diagnosing disease, in treatment as well. What are the consequences? And in understanding the consequences is how the foundation of a safe practice is being established. Without understanding radiation biology, you cannot practice radiation safety, and you're putting the public, the patient, at a very, very high risk. Now, what is radiation protection? And when you talk about radiation protection is basically just the science and the practice of minimizing radiation exposure. And the minimization of this radiation exposure is to three people. First and foremost is your patient. Your patient is the primary recipient of this exposure. And for your patient, the first thing you do is you should be sure that the x-rays you are taking, or if it's the use or dispensation of radiation, must be justified and optimized. And when you are saying justified, you are looking at, does the benefit of this radiation, does it outweigh the risk? What's the importance or what's the good that radiation does? This radiation that I'm exposing this patient to, what would it do to the patient? Then when you talk about optimizing, okay, if eventually this radiation dose that I'm giving this patient is justified, or this examination is justified, what is the dose we are supposed to expose this patient to? Right. So like that's why we say Alara principle, as low as reasonably achievable. That is, the dose that this patient is being exposed to is small, right? Yielding a very good diagnostic or therapeutic result. Secondly, the other people we would be looking at is radiographers and radiologists. These are the staffs there, because in as much as these people are the in as much as they are the primary recipient of radiation, right? They are also the radiographers, the staffs, those working there, the healthcare workers, the nurses, the technicians, the assistants. They also need to be protected from occupational exposure, right? Um, Another area, another people we look at when we are protecting, or people we protect, they're the public. We have people in the hospital, in the diagnostic center, waiting in the waiting room, or visitors, or the general community themselves. They also must be protected from unnecessary exposure. And speaking of the radiation protection, they are not just a set of rules, they are professional and ethical responsibility that everyone needs to follow to create a very, very, very safe environment, even while trying to help medicine, help diagnosis, help the patient, and also help the public. Now, we cannot look at radiation protection or radiation biology without looking at or giving credit to the discovery of X-rays. X-ray was discovered in 1895 by William Röntgen, and it was a revolutionary breakthrough where doctors could finally see right inside the body without surgery. Certain procedures can be performed without invading. We call them non-invasive procedures. And for in whatever they call it in your country, either radiation radiographers or medical imaging technologists, we call us the eyes of medicine, right? Because before treatment, before surgery, before anything is administered to a patient, the doctors need to stake a diagnosis. They need to see, okay, which area is the tumor located? Oh, where is the bone? Where are the bones broken? Where can you see your pacification, calcification? Through which channel can we treat the patient? What's the pathway? So many of these hidden truths are made known to them through pictures, right? Um, So that was what brought about the discovery. And but at that time, early users they had no protection; they used it carelessly. If you read through the history, right, which we're going to have a separate video, many of them took pictures of their different parts of the body and gave it as souvenir in different events. Even at that time, um, radiographers and radiologists they held patients' hand in the exposure field. They could even put their hand in the radiation field and take an exposure of their own part of their body, keeping the patient at rest. Don't worry, this is not going to harm you. Just see how I'm doing mine. So they used it carelessly, and after a few years, we began to notice radiation injuries, different types that appeared. You have your skin burns, hair loss, cancers, and the likes. And they were called X-ray burns or Röntgen's dermatitis, either of these two. Yeah, so at that time, a lot of those things became obvious. Even many of those radiologists, radiographers, they had their hands being cut out, air losses, and the likes. Now, let's learn from history. From the history, we could see that from the brief history we gave, early radiologists developed cancers on their hands after a few years. And this occurred, like I explained, that from holding patient during X-ray examinations, from just some of them might just say, okay, let's test, just put their body, oh, let's test it on my wife, let me do this on my family members and the likes. Many even died. Many died. The tragic history led to, but this whole event led to researchers themselves going to go and study, okay, what is the cause? How does it affect? What's the negative effect, and what's the channel or the process by which this effect occurred? So it led to development of this whole research led to development of radiation protection standard. And to be honest, today we owe it to those early pioneers. Their sacrifices taught us the need for protection. At that time, it might look like they lost their hand, they lost this, they lost that. But if they had, thank God that they discovered that, and they did not just leave it at discovery, but they also went ahead to map out some radiation protection strategies that has helped us to today. Now, let's take a look at radiation protection organizations. So, there are international organizations that have actually guided or that is guiding radiation protection. And the first one we look at here is the ICRP, that stands for the International Commission on Radiological Protection. What do they do? The ICRP they set the framework for radiation protection and also the recommendations. So some of which can hear Alara principle. You can you would there's a point where we get to see the dose that a worker occupational exposure, what's the dose for occupational exposure, what's the dose for the public, what's the maximum dose for student and all of that. So the ICRP are those that sets those frameworks and recommendation. You have the IAEA, the International Atomic Energy Agency, and these ones they promote the safety standards. They promote it, they encourage it. Then the last one from my note here is the ICRU, the International Commission on Radiation Unit. This one's they define the measurement units. The measurement unit. And this organization, they what did they do? They ensure that there is consistent and science-based protection worldwide. Everyone is protected. Everyone is protected because everyone is at high risk. But putting all these rules, recommendation, promotion, unit measurements set in place by this international organization, right? It helps to protect the world in general. It helps to, in fact, if there were not to be protection, I don't think I would um be practicing as a radiographer. I might just study since we don't really enter radiation field, but I won't practice as a radiographer. But thanks to them. Now, Well, now let's look at it. Why is radiation harmful? Why is radiation harmful? The answer lies at the cellular level, right? Radiation energy to the atoms and molecules in the body. What do? They transfer energy, like I said, cellular level. And I already explained from the beginning that the radiation, when a patient is exposed or anybody is exposed to radiation, it transfers energy to the atoms and the molecules in the body. And when they transfer energy, different things occur. They could just pass if it's a non-ionizing radiation, but because it's an ionizing radiation, right, the energy can ionize atoms. That is, when you say ionize, it can remove an electron out of an atom, creating a charged particles called anions. Anions. These ions can break chemical bonds, and breaking these chemical bonds, right, can cause free radicals that highly react with your molecules, and this in reacting with the molecules, they causes the damage to the DNA and other cellular structures. If the DNA is damaged, the cell can die or become cancerous. And this is the basic mechanism of radiation injury. So at this point, remember, let's go from the beginning again. The energy, when they are deposited in the atom, what happens? They ionizes the atom. They are sufficient enough to displace an electron from its orbital shell, and when they displace it, right, ions are formed. It becomes very unstable, and that's its instability is what creates what you call your free radicals. And these free radicals, they react with the DNA and causes damage to the DNA. So is this DNA being damaged, right, that causes the cell to die because it cannot reproduce again, and they become cancerous at the long run. But in some places, two things can occur. First, the DNA damage. Two outcomes can occur as a result of DNA damage, either repair or misrepair. So when you talk about repair, the cell itself, all right, have a repair mechanism where they fix the DNA damage. But these repairs are not always perfect, right? Sometimes the damage is misrepaired, that is wrongly repaired, which leads to gene mutation that also causes cancer in people that in generations that comes after whoever has accumulated this exposure. So accumulated mutation can lead to cancer. So this is why radiation exposure is a risk, even in small amount of quantity. So even small amount of radiation carries some probability of long-term effect. That is why one needs to be very careful, and safety measures need to be put in place. Now, let's go to Alara. We talked about Alara, and Alara is the foundation for any type of protection. Mind you, we are still in the introduction. The Alara principle is the foundation of radiation protection. And what does Alara stand for? It stands for it's already there, as low as reasonably achievable. Right. So this is one foundation to radiation protection, as low as reasonably achievable. This means one must keep your radiation dose as low as possible, still yielding a very good diagnostic information that we need. The word is reasonable. The key word is reasonable. So you should not reduce it too low that even when you eventually take the exposure, you're not having a very good image quality because it will still call for repeat. And repeat of examination, right, exposes the patient to more radiation. So that's why we write reasonable, as low as reasonably, the one that can achieve a good result. So we balance the benefit of the procedure against the risks of exposure. If a procedure has no benefit, don't do it, right? And that's where justification comes in place that we'll still talk about. But as much as possible, should be able to yield good results. Be able to yield good results. Now, under that, what are the principles of protection that we have? The first in is justification. And when I talk justification, you're talking about, is this exam necessary? Right? Is it necessary at this time? Is there any other modality that can be used to bring out the solution? And let me give you an example. For a pregnant woman at the first trimester that comes to do, it says, I'm feeling stomach pain, right? That comes and the doctor says, okay, come and do x-ray. By the time the patient gets to you, you know that because of the baby inside of the mother, this woman, the baby is at risk and the mother is at high risk as well of gene mutation and like we already talked about. So you look at it to justify that this woman should do, does the benefit outweigh the risk? Is there another examination she can do to get the desired result she wants? So these are the things you need to look into before you go ahead with the procedure. And if at that time there is another test you can do for the woman, she could go do an ultrasound, right? Just to ensure that the you are complying with the justification, we say that the benefits must outweigh the risk. And in terms of optimization, okay, optimization, Alara, those dose that you want to give, you should be able to give a dose that is well optimized, a low dose that can yield a good diagnostic quality, avoiding repeating the examination and not giving too high that exposes the patient to more radiation. Then when you talk about limitation, those limit, that is whatever dose you are giving to your patient must be within the acceptable limit. So, with these few things, we are done with just the introduction. So, this is just the introduction, and we would go to more in depth. And today we talked about radiation biology, what it is, radiation protection, some history, looked at Lara principle and the three major principle in radiation protection. I hope you've learned something. Just like, follow, and share for more videos. You can just check through. It's a series, and this is just the beginning. As we progress, we tend to go into it in depth. So this is learning imaging tech. Do like, share, and subscribe. Thank you.